morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about problem solving on hit or miss transformation. The hit and miss transformation is a general binary morphological operation that can be used to look for particular patterns of foreground and background pixels in an image. It is actually the basic operation of binary morphology, since almost all the other binary morphological operators can be derived from it. Hit or miss transform is an operation that detects a given configuration in a binary image using the morphological erosion operator and a pair of disjointed structuring elements. The result of the hit or miss transform is the set of positions where the first structuring element fits in the foreground of the input image and the second structuring element misses it completely. So what are the morphological operations? Erosion, dilation, so the morphological operations are basically 5 types: erosion, dilation, opening, closing, hit or miss transform. In the previous sessions, we have completed erosion, dilation, opening and closing. Today I am discussing about hit or miss transform. Hit or miss transform is a general binary morphological operation that can be used to look for particular patterns of foreground and background pixels in an image. Actually, the basic operation of binary morphological, since almost all the other binary morphological operators can be derived from it. Hit or miss transform is an operation that detects a given configuration in a binary image using the morphological erosion operator and a pair of disjoint structuring elements. The result of the hit or miss transform is the set of positions where the first structuring element fits in the foreground of the input image and the second structuring element misses it completely. So, the structuring element used in the hit or miss is slightly extension to the type that has been introduced for erosion and dilation, in that it can contain both foreground and background pixels rather than just foreground pixels, that is both ones and zeros. Note that the simpler type of structuring element used with erosion and dilation is often depicted containing both ones and zeros as well. But in that case, the zeros really stand for don't cares and are just used to fill out the structuring element to a convenient shaped corner, usually a square. So, morphological operations are structuring element used in hit or miss transform, and this is slightly extension to the type that has been introduced for erosion and dilation, in that it can contain both foreground and background pixels rather than just foreground pixels, that is both ones and zeros. Note that the simpler type of structuring element used with erosion and dilation is often depicted containing both ones and zeros as well. But in that case, zeros really stand for don't cares and are just used to fill out the structuring element to a convenient shaped kernel, usually a square. Okay, so when I'm going for the morphological operation, so these are all I need structural element. I need the structural element. Suppose I'm taking erosion or dilation, whatever may be, it is the A and the structural element is the B. So if I'm performing A plus B, if I'm performing A minus B, if I'm performing A circle B, if I'm performing A dot B, so any of this one, any of the structural element, A with A complement, B with B complement. So any of this one, I need the matrix of eroded matrix, dilated, hit or miss, opening and closing. But the structural element is needed. The structural element maximum we are taking as a 3 by 3 matrix. It is like a 1 0 0 1 1 1 1 1 like this. Okay. So suppose I am taking structural element as a 2 1 0 1 1 example. Suppose I am taking structural element as like this. Okay. So like this, any of this one. Okay. These are all structural elements. So these don't case are shown as blanks in the kernel. Okay. So don't care is nothing but a blank. In order to avoid confusion, an example of the extended kind of structuring element is shown in the figure 1 below. As usual, we denote foreground pixels using ones and background pixels using zeros. Okay, already we know that in the previous sessions, foreground equal to foreground I'm taking as a 1, background I'm taking as a 0. So foreground equal to 1, background equal to 0. So when these are all zeros means these are all belongs to background. So what are the remainings are there? These are the don't care. Don't care is nothing but a blank in the kernel. Don't care means nothing is there. So when I want a foreground and I background. If you want a foreground, you can keep as a 1. If you want a background, keep it as a 0. Suppose one person is there. In that person, background is one photo frame is there. So it is a foreground and it is a background. So foreground, how many cells are there? You can keep as a 1. Background, I want to highlight 1. So remaining all, what are the remaining gaps are there? You have to 0. Suppose between the image and the photo, some gap is there now, you can keep as a 0. Only background I am highlighting, only object is highlighting. Okay, you want to highlight the foreground, keep 1. You have to highlight the background, keep 0. If you don't want anything, we are going for the don't care condition. So here don't care is a blank in that kernel in order to avoid confusions. An example of the extended kind of structuring element is shown in the below figure. As usual, we denote the foreground pixel using ones, in the background pixel is 0. Extended type of structuring element used in hit or miss operation is particularly element can be used to find the corner points. So it is extension to this example. Here we can observe here only 1 1 1s are like this. Okay, 0 zeros are like this. Okay, So 4 structuring element used for corner finding of the binary image of the hit and miss. Okay, it is 4, 1, 2, 3, 4. So 4 structuring elements. Note that they are really all the same element but rotated by different amounts. So here my object is like this. 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 So where your object, you have to change it. Suppose my object is I have to move. You can move to left, right, bottom, top. Okay, when the object is highlighted, you can tag one. I want to highlight the background. I want to move the background. Okay, any of those things you can move as a one. So foreground equal to 1. Background equal to 0. Okay, so don't care means nothing is here. Okay, blank the cell. Okay, so these are the blank cells means I'm using as a don't care conditions. Okay, these are the don't care conditions. So the hit and miss operation is performed in much the same way as morphological operations by translating the origin of the structuring element to all points in the image and then comparing the structure element with the underlying image pixels. You have to apply the hit or miss operation is performed in much way. What is the morphological operator using? So the same origin of the structure element of the morphological translating origin of the image, then comparing the structure element underlying there. Okay. So any of that hit or miss transform, you have to apply the morphological image. That means input image with segment image, structural element. Then only we have to get the hit or miss transform or eroded or dilated output. So we are comparing with the structure element with the underlying image pixels. If the foreground and background pixels in the structuring element exactly match foreground and background pixels in the image, then the pixel underneath the origin of the structuring element is set to the foreground color. If it does not match, then that pixel is the set of background color, and the structuring element shown in the figure can be used to find the right angle of the points in image. We are noticing that the pixels in the element to form the shape of a bottom left convex corner, and we are assuming that the origin of the element is at the center of the 3x3 element. So I want to highlight the foreground. I want to highlight the background. If you highlight the foreground, you have to take all the cells are 0. If you highlight the background, you have to highlight the background. Then you have to keep as a 0. If you don't want anything highlight, I want to don't care condition. That means black the condition. So the foreground and background pixels in the structuring element exactly match foreground and background pixels in that image. But the pixel underneath the origin of the structure element is set to the foreground pixel. If I don't want any, doesn't match anything, so you have to keep it the blank in the pixel and to the background of the color. Suppose I want to gray to the color. So you can keep it as a gray to color or color to gray. So we have some notices in the pixels that the element to form the shape of a bottom left convex corner, we assume that the origin of the element is that the center of the point with the 3x3 element. So maximum 3x3 element is nothing but I am taking as a structural element. In order to find all the corners in a binary image, we need to run the hit or miss transform 4 times with the 4 different elements representing the 4 kinds of right angle corner found in a binary image, shows the 4 different elements used in this operation. So here, suppose input image is there. To rotate with structural element is there. So in order to find all the corners in a binary image, we need to run the hit or miss transform 4 times with the 4 different elements. In the previous we discussed, in the 4 diagrams are there. So we are rotated left, right, top, bottom. So in that corners in the binary image, we need to run the hit or miss transform 4 times with the 4 different elements, representing the 4 kinds of right angle corners found in binary image and the 4 different elements used in the operation. So rotate, or highlight So we have to rotate the foreground or background or highlighting or foreground as background is changed. Structural element is used for structural element used structural element used to perform all the morphological operations. The hit or mistransform. The hit or mistransform of a binary image A by B is denoted by A into B, and B is a pair of structuring elements. Already we know that. And B equal to B1 comma B2. Then a single element B1 equal to set of elements B1 set of elements of B associated with an object. B2 equal to set of elements of B associated with the background. Okay, object is nothing but a foreground. It is a background. Okay, so B1 and B2. B1 is an object. So the hit or miss transform of an image A by B is denoted by A into B. B is a pair of structuring element, that is B equal to B1 comma B2, that is object with foreground rather than a single element. Here B1 equal to set of elements of B associated with an object. B2 equal to set of elements of B associated with background. Hit or miss transform is defined as follows. Okay, so A to B is equal to A combination of B1 with A complement of B2. This transform is useful in locating all pixel configurations that match the B1 structure, that is hit, but do not match with B2, that is a miss. Thus the hit or miss transform is used for shape detection. So if I am taking B structure, if B1 hit, B2 miss. If B1 miss, B2 be hit. So B1 structure is do not match with B2. Thus hit or miss transform is used for detection. If I am taking one example, use the hit or miss transform to identify the location of the following shape pixel configuration in the image below using the two structural elements B1 and B2. Okay, it is the shape of this one. So what is the shape means? I am taking 3 by 3 pixel, and here I am taking as an image. So I am doing the B1 and B2. Already we know that what is the B1 for object, B2 is for background. For this cells, if I want to highlight the background, then I am taking as a 1. If I don't want to object, you have to find out, then you have to take 1. If you want to highlight the background, then backgrounds are 1 and object is empty. Here object is empty, background is 1. So object is I want to highlight, then you have to object is you have to take the 1, remaining 1 like this. Okay, so what is this one? it is a erosion process. A eroded B, A complement, A eroded B2. So after the complement, A complemented with B2 is nothing but a background. Okay, it is a erosion and it is a dilation. It is the opening. Okay, opened output. In the below figure shows an example of applying the hit or miss transform on the image in the previous example. From the previous example, what is the final image? It is a binary image. Okay, it is a input image. Okay, result of applying hit or miss transform. So hit or miss transformed output. What happened here? Background. So the object equal to 1 and the background equal to 0. So in that image, what you want to highlight? So here only I'm taking, I want to crop this one. Only I have to highlight this one. Remaining all I don't want to highlight. Okay, remaining what are the white cells are there? I'm converting to the black. So here also only this one I need. So remaining object is converted to the black. It is also converting to the black. So white is converted to the black. So binary image is the result of applying the hit or miss transformations. So here what you want to highlight, you can highlight with white, that is 1, and what you want to not be highlighted, that is you have to take the black is 0. Okay. So therefore the hit or miss operations are comprising the 3 steps. Eroded image A with a structuring element B1, eroded the complement of A with a structuring element B2, and the result of step 1 and step 2, the structuring elements B1 and B2 can be combined into a single element. Okay, so here the hit or miss operation are the 3 steps are there. Erode image A with structuring element B1 I'm taking. Here eroded image A, eroded the complement A complement or AC, A complement with structuring element B2, and result from step 1 and step 2. The structuring elements B1 and B2 can be combined into a single element. Okay, so eroded So here eroded input image is A and the structuring element I'm taking as a B. Okay, here I'm taking as a B1, but for the structuring element, here B2 is the complement, A complement with the structuring element B2. So I'm combining the results of A and gate, and means B1 into B2. So B1 into B2. So the structuring element B1 and B2 can be combined as a single element B. So here structure element left to right. Here I am taking first left. It is the input image. Structure element. So hit the middle to miss the right final combined. So what is the first one here means left side is a hit and middle to miss. Right is a final combined. So what are the middle point I am taking? Highlighting one. Okay, it is a object. Okay, it is a background. So background I am highlighted with 0 and object highlighted with 1. Here Here the mistransform is there. Okay, the mistransform is taken as a -1. So in this case we are looking for a pattern in which the center pixel belonging to the background, while the north, south, east and west pixel belong to the foreground. The rest of pixels in the neighborhood can be of any kind. We don't care about them. Now let's apply to this input image. In the top of this image, apply the hit or mistransform. In this case, we are applying or looking for a pattern in which the center pixel belongs to the background, while the north, south, east and west pixels belong to the foreground. And the rest of the pixels in the neighborhood can be of any kind. We don't care about them. And let's apply to this of the input image. Okay, so here 255 means it is a white. So I'm highlighting this one. It is 0 means black. So here only one cell highlighted. That is white. So here background equal to 0 and object equal to 255. Here majority, here more objects. Okay, it is an input binary image, output binary image. Okay, I reduced the white cells or not. Okay, there are so many of objects are there, but I want to take only one object, that is a 255. Remaining on I want to convert to 0. Okay, these 255 are converted to the 0 at the output with the help of hit or mistransform. And it is an example to suppose we have to find a T-shaped pattern in the image and defined by the SC_B1 such that it does not contain the pattern defined by B2 at the right hood 0. Below representing that we don't care about these positions. Below figure shows how to combine two SCs into the one. Okay, it is the input image. Okay, here T shape. So I want to take the T shape of this one. Okay, so what I can do? So this one I want to for the don't care. 0 means it is a background and it is a foreground or object. So here object is T-shaped with 1 and the background equal to 0 and don't care conditions are taken as a -1. That is a don't care condition. That is a blank. It is a combining of B1 and B2. It is a B1 with B2. Okay, and now just to compare the underlying pixels values with the combined structure element. If it is matches exactly, then pixel underneath of the origin SC structure element is set to 1, else it is 0. And let's take an example. Suppose we want to find above combined SC in the image shown below. Clearly one of the lower right matches the pattern defined by the combining structure element. The result is shown in the right side. Okay, I'm taking the original image as an input image. So only one object is there. So object equal to white equal to 1. So hit or mistransform as applied here. What are the white cells are there? I was removed only one cell. Okay, I don't want these are all. Only I have to take this one. Only I have to highlight this one. So it is the advantage of this one. So we can just comparing the underlying pixels values with the combined structure element, and if it is matches the exactly, then the pixel underneath the origin of SC is set to 1, else it is 0. And let's take an example of following to find the above combined SC structural element. element clearly one of the lower right matches the pattern defined by the combined structure element, and the result is showing as a right side with hit or miss transform. And what are the terminologies in morphological image processing? All morphological processing operations are based on mentioned terms with the structuring element. It here structure element is a mandatory for this one. It is a matrix or a small sized template that is used to traverse an image. The structure element is positioned at all possible locations in the image, and it is coupled with the connected pixels. It can be of any shape. What is a fit? Fit when all the pixels in the structuring element cover the pixels of the object. We call it fit. Hit when at least one object pixel in the structuring element cover the pixels object. That is a call in hit. Miss when no pixel in the structuring element in the cover the pixels of the object. We can call it as a miss. So morphological processing operations are based on the mentioning terms. So morphological operations, SE, and what is a matrix I need? So structure element with transformation matrix. So if the matrix of a small sized template is used to traverse an image, the structure element is positioned at all the possible locations in that image and is compared with the connected pixels. It can be of any shape. Fit when the pixel of the structuring element covers the pixel of the object. Okay, if I'm taking it is a fit object and it can be of any of the shape. It is a fit. Hit when at least one of the pixel, any of the one. So full match equal to I'm taking as a fit, partial match. So full match equal to fit, partial match equal to hit, no match equal to miss. Okay. So it is one example of it is a original input image. It is a original of dilation and it is a erosion. So what is a dilation means? Here the shape here reduced here. Okay, we are converted to this one. Okay, we remove this one, and it is like a it is the width is very high. Here we reduce the width. Here it is a dilation, and erosion means we are break this one. This object, two objects are there. It is a object one, object two, and it is a closing operation. Only same thing is there. Dilation operation is eroded. Erosion is compared to the dilation. Okay, so first dilation, after then erosion. Here first erosion, after then dilation. So closing and opening. So what is the final thing means? Closing it is nothing but a object is same but partially changed. Here opening means the objects are breaked. Means white, what are the black colors are there? We are reduced. Okay, that is a opening. It is some example suitable with this, and these are the references. Okay, I'm taking. So when so when I'm taking the structural element is SC. So in this structural element, if the full matched is there, that is called fit. Partially matched, that is hit, mismatch. Suppose I'm taking one image. Suppose I'm taking any of this one. So only this one is highlighted. Only if it is matched, so it is a hit or not. Yes, it is a fit. If partially matched, if I'm taking like this, okay, 1 1 1 1 1, okay, only one is matched, that is a partial match. If no matching means, here I'm taking and keeping like this, here all ones are there but all backgrounds are 0, it is no match, that is the missing is there. So in the hit or match transform is a general binary morphological operation that can be used to look for particular patterns of foreground and background pixels of an image. Actually, the basic operation of binary morphological is almost all the other binary morphological can be derived. And a hit or miss transform is an operation that detects a given configuration in a binary image using the morphological erosion operator and a pair of disjoint structuring elements. The result of the hit or miss transform is a set of positions where the first structure element fits the foreground of the object and the second structure element misses completely. And the structuring element used in the hit or miss is the slight extension of the type that has been introduced for erosion and dilation. In that, it can be contain both foreground and background pixels rather than just foreground and background pixels of both ones and zeros. And the simple type of structuring element used with erosion and dilation is often depicted containing both ones and zeros as well. But in the case the zeros really stand for don't cares and are just used for filling the structuring element to a convenient shape of kernel. So the don't care condition is nothing but a blank. When the cell is blank, that is a don't care condition. That is a don't care condition. When the one is there, foreground or object. When the 0 is there, that is the background. So these are the 4 different structuring elements used for finding the binary image of hit or miss transform. The hit and miss transformation is performed in much the same way as the other morphological operations by translating the origin of the structuring element at all the points of the image, then comparing the structural element with underlying image pixels. And the foreground and background pixels in the structuring element exactly the match of foreground and background pixels in the image, then the pixel underneath of origin of the structural element of the foreground color. If does not match, that is the empty or blank for the background color. But we are assuming that the original element is an center of 3 by 3 element. In order to find all the corners in a binary image, we need to run the hit or miss transform 4 times of the 4 different elements representing 4 kinds of right angle corners to found in the binary images of the figure 1 shows the different elements used in the image. So if I am taking the image with the foreground and background, we are rotating the foreground and background with the structuring element. Okay. So the hit or miss transformation of the image A by B denoted by A with B, and B is a pair of structuring element B equal to B1 into B2 rather than a single element. B1 equal to set of elements of B associated with an object, B2 equal to set of elements of B associated with the background, and the hit or miss transform is defined as follows with A to B. And this transform is useful in locating all the pixel configurations that match the B1 structure, that is a hit, but do not match with B2, that means miss. Thus, the hit or miss transform is used for shape detection. It is one example of the hit and miss transform to identify the location of the following shape pixel. Here I am taking the 2 structuring elements B1 and B2. So, B1 is for object. So it is a complement and A eroded B and A dilated B with and A closing and opening operations. Here final operation of input is in image. It is a final hit or miss transform output. So there are 3 steps of hit or miss operations are there. Eroded image A with the structuring element B1, eroded A with the complement of B2, and AND operation of step 1 and step 2. AND operation means I am taking as a B1 with B2. And it is a hit transform, it is a miss transform. -1 is nothing but a don't care condition. And it is looking for a pattern which the central pixel belonging to the background, while the north, south, east and west pixels are belonging to the foreground. And the rest of the pixels of the neighboring hood can be of any kind, we don't care about them. And let's apply it to the input image. Here, when we have to highlight, I have to take the pixel of 255. When you don't highlight, it is taking as a 0. So if I'm background equal to 0, that means background equal to 0 means that is a black. Then object is 255, then it is a white. Okay. And we are taking as the example to, I want to highlight the T-shape. I don't want anything. I want to highlight the T-shape. So when we have to highlight, we have to take 1. When we have to don't highlight, I'm taking 0. When you have to don't care, means I don't want objects. I want to remove those things, taking as a -1. So B1 and B2 combined with this one. B1 with B2. Okay, it is a final output. Okay, and now just to compare the underlying pixel values of the combined structure element. If it is matches exactly, then the pixel underneath of the origin of structure element 1, else 0. And the example to find out the about combined structure element in the image shown below. One of the lower right match of the pattern defined by the combined SC, the result is shown by the right side. Okay, it is the output of highlighting. So remaining all background is not highlighting. It is the hit or miss transform. And what are the terminals of morphological image is that the morphological operations are based on the mentioned terms. So what are the structure elements I'm taking? It is a matrix of small sized template that is used to traverse an image. The structure element is positioned at all possible locations in the image and is combined with the connected pixels. It can be of any shape. If I'm taking the fit, hit and miss transform, fit, hit and miss. Fit is nothing but a completely covers. Hit is means partially covering, and the no matching means I'm taking as a. It is one example of original image with dilation and erosion, erosion and dilation. It is the output of closing. It is the output of opening. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.